Okay, this is chapter 1, section 3, and we're going to go through 1.3. This is describing quantitative data with. So, in describing quantitative data with numbers, we're going to look at a box plot, and we're going to talk about kind of the 5-number summary as we go through a few of these things. So let's talk about first a box plot. You see that we have a minimum value, which is kind of, a lot of people refer to that as the end of the whisker of the box plot. Then we have Q1. That's the first quartile, or the 25% mark. That would be where the box begins. We have the median somewhere inside of the box. Q3 is the 75% mark. That would be the third quartile, or where the box ends. And then we have our maximum, our next highest value. The fences are where we will calculate what an outlier would be. And if a data point falls outside of our fence, then it will be considered an outlier. So if you see these fences here, that won't be drawn on your box plot, but it is just a reference to why this is an outlier, because it was bigger than that number. So it has become an outlier. So the first thing we're going to look at is the center. So on a box plot, we're going to use the median. And the median is the midpoint of a distribution. And the midpoint is just where half of the observations are smaller and the other half are larger. So to find the median, you can arrange them all from smallest to largest and go through. But the best thing to do is to go to Stat Edit on your calculator and then go into Stat Calc, one variable stats, and to find the median when you scroll down. So go into Stat Edit, type in your numbers, go to Stat Calc, and scroll down, and you'll see the median there. So after this section, we hope that you'll be able to measure the center with the mean and the median. You'll be able to measure the spread using the standard deviation and interquartile range. You'll be able to identify any outliers that there are, construct a box plot using this 5-number summary, and calculate some summaries using your calculator. So the mean and median measure the center in different ways, and both can be very useful. The mean is the average value, so that's what you typically do if you want to find your grade or something like that. You add them all up and divide by how many there are, and that gives you the average, like what was your average score. The median is a typical value, so it's like the middle point. So it's not necessarily the average, but it's the one that's in the middle. There's 50% that are below and 50% above. The relationship between the mean and median, they should be very similar to each other if you have a roughly symmetric distribution. But if the distribution if it is exactly symmetric, the mean and median will be exactly the same. However, in a skewed distribution, the mean actually gets pulled. It's called a non-resistant measure of center. The mean will be pulled with the skewness. So if it's skewed to the left, if there's a tail to the left, then the mean will get pulled down to the left. And if it is skewed to the right, then the mean will get pulled up to the right. And that's what gives us the difference between the mean and the median. So here is our notation, or how we would talk about the mean. The mean is the sum of all our observations, so adding them all up, divided by the number of observations you have. And in your formula sheet for AP Statistics, it is listed like this. X bar stands for the mean. That equals the summation, that's that symbol there, of all your x's divided by the number of terms you have. So why is the mean more affected by outliers than the median? Because the mean is the average. So think about it. If you have, for instance, if you have a group of employees that make $10 an hour, and then so let's say you have 4 employees that make $10 an hour, and then you have a 5th employee that now makes $100 an hour, then the mean is going to be, you're going to add them all up, you're going to get 140 divided by 5, which is 28. So they could say, hey, the average salary is $28 an hour. But if we're looking at the median or typical salary, it would be that third one, it would be $10 an hour. So the mean is more affected by an outlier, such as like the CEO's salary or somebody that's worked a long time at the company. So here's how you can calculate the standard deviation and the mean. You can, without using the TI Inspire, with just using a regular calculator, what I would say is type the values into list one. So go to stat edit and then put them in list one. Those are your values that you want to enter. With your cursor, go to stat calc and then go to one variable stats, and you'll see that X bar at the top. So X bar is the one at the top, and you'll select what, or when you go to stat calc, you go to one variable stats, and then you'll select the X bar. That's your mean. And you need to know how to calculate the mean and standard deviation with your calculator, and I think that will work a whole lot better. Okay, to calculate the standard deviation, you'll see the sigma sign. It's a circle with a line over it. You also see SX. We'll talk about the difference between each, but for right now, either one will be sufficient. So standard deviation, a relatively low standard deviation indicates that the points are very close together. If you look at that image to the right, a small standard deviation means that all of our data is very close to the average, very close to the mean. A large standard deviation means that all of our data is further away from the mean, like it's more spread out. So that's the difference between a small and large standard deviation. So the standard deviation formula is SX, so you can find that in your calculator. And it's a long formula, but remember, when you do the formula, what you're doing is you're taking each individual data point and subtracting the mean and squaring it. And we're going to make it into a table for you to show you. Now, I'm going to show you how to do it by hand, but then we're also going to go back and show you how the calculator will do it as well. But we really want you to understand what standard deviation means. And standard deviation is the measure of the average distance of the observations from the mean. So like when you get a small standard deviation, you need to know that on average, this is how far they are from the mean. And so for instance, if I'm given a test and it has a small standard deviation, then I know that a lot of students scored very close together. If my test has a really large standard deviation, then I may know that some students scored really low and some students scored really high, right? And I may need to go into that a little bit clearer. So standard deviation plays a big role in analyzing data. The interquartile range, if you're not familiar with that, sometimes it's referred to as the IQR. And that is Q3 minus Q1. So if you look at a set of data, Q3 is the 75% mark. And Q1 is the 25% mark. And so Q3 minus Q1 will give you the middle 50%. So that's what the IQR is, the interquartile range. It's that middle 50% of your data. And so now I come up with two extreme examples. So let's look at this. In data set 1, we have 5 people that report eating 4 pieces of cake and 5 people that report eating 6 pieces of cake. So the mean, when we add all these together, is 5. The variance is 1, and we'll talk about variance later. Variance is standard deviation squared. It's a measure of how much the observations vary from the mean. In data set 2, we have 5 people that report eating no cake and 5 people that report eating 10 pieces of cake. So we get a mean of 5 pieces as well. But we notice that the variance here is 5, which would mean a higher standard deviation. So you can see how when the students or when the people are very close together on how much they eat, we'll end up with a very small standard deviation. When people are far apart on what they eat, we'll get a very large standard deviation. And if they ever give you the variance and you need to find the standard deviation, you need to make sure you know that the standard deviation is just the square root of the variance. And if you ever have the standard deviation and you need to find the variance is just the standard deviation squared. So that's their relationship with each other. So interquartile range, we already talked about how to calculate that. It's just Q3 minus Q1. I would do that on my calculator. And then here are three different distributions, A, B, and C. And you want to see which one has the largest standard deviation. So which one has the most data points that are away from the mean, okay? Because we're looking at the average distance is the furthest away from the mean. So I'll leave that for you, and we'll come back later, and I'd like to ask what your answer is for that. So next, then the very next question asks to find and interpret the IQR. So this is 20 randomly selected New Yorkers. So your goal here would be to take out a calculator or to use the calculator on your computer, but I would take out my TI-84 calculator and go through. And if you don't have one of these, Amazon is a good spot to find one. You can also get one from Walmart. But I would suggest in AP statistics to try to get your hands on one of these if you can, and you would be able to use it throughout college. So they're not going to go anywhere. I recommend this one. It's the TI-84 Plus CE, which is the newest edition. I think it runs you about $100, but it would be something that you would use for many years, especially with learning being online. I think that would be very beneficial. So we're going to go to Stat Edit, and this screen appears, the list one, and I'm going to type in my numbers. So 10, 30, 5, 25, 40, 20, 10, 15, 30, 20, 15, 20, 85, 15, 65, 15, 60, 60, 40, and 45. And feel free to pause the video when you're entering the data if you need to slow down. So type my numbers into list one. To find and interpret the IQR, first I'm going to go to Stat Calc. I'm going to go to one variable stats, and I'm going to calculate. And I'm going to scroll down, and I see Q3 is 42.5, and I see Q1 is 15. So it's going to be 42.5 minus 15, which ends up giving you 27.5 minutes. So that is our IQR. Now, the interpretation of that goes back to the problem is travel times. So the middle half, or the middle 50% of travel times for New Yorkers is 27.5 minutes. That's the middle part. It's between 42.5 and 15. That's where that middle 50% of New Yorkers, that's how long it takes them to travel. Now, for the first time, we want to look at an outlier. How do we calculate an outlier? The formula to calculate an outlier is 1.5 times the IQR. So the IQR in this problem is 27.5. And if we put in our calculator 1.5 times 27.5, we end up with 41.25. We're going to take that number and subtract it from Q1, so our lower quartile. So we're going to say 15 minus 27.5. That is the lower fence. Anything below that number is an outlier. So anything below negative 12.5, which we know there can't be anything below that because you can't have a negative travel time. But anything below negative 12.5 would go through, and it would, 15 minus 41.25. So anything below negative 26.25 would be an outlier. And then we're going to say our Q3, which is 42.5, we're going to add 41.25 to that, and we get 83.75 as our upper fence. So anything below negative 26.25 would be an outlier. and anything above 83.75 would be an outlier. So now we go back and look at our data. Is there anything there? And what we notice is that you see that time of 85 minutes, right? So you see the 85 minutes would be considered a high outlier. Identifying outliers, we just talked about there. In addition, the interquartile range is used to identify outliers. So what you will do is you will take 1.5 times the IQR. You will add that to Q3 to get the upper fence. You will subtract it from Q1 to get the lower fence. And the reason we call it a fence is because anything that is within that fence is not an outlier, and anything that is outside of that fence would be an outlier. So next I want to take you to the 5-number summary. If you're still in your calculator, if you go to stat calc number 1 and scroll down, you will see, as far as you scroll, you will see the min, Q1, median, Q3, and max. That is your 5-number summary, and that's going to be how you create a box plot. Min, Q1, median, Q3, max. So we can calculate the outlier cutoffs. We already did that, but and I'm going to skip past the TI Inspire and go to ours. So when we do this for the New York travel times, I see a minimum of 5. My Q1 is 15. My median is 22.5. My Q3 is 42.5. And my maximum is 85. And you see that posted right here in this right slide. Now, remember, all of these are going to be dots for the 5-number summary to make the box plot. The only exception is 85 is an outlier. So we will put an asterisk or a star there for 85. And then we go to the next biggest number, which is 65, and that becomes our new maximum in the 5-number summary. So as you're making this box plot, let me scroll down. As you're making this box plot, you would, the minimum of 5, let's see if I can draw this for you real quick. The minimum of 5 would be here, and then 15 would be right here maybe. 22.5 would be here, 42.5, 65, and then 85. Now, the minimum would be aligned to your Q1, and then Q1 would start the box, and then the median would go right here. That would be a line in the middle, and then from Q3 to the max is your whisker, and then this 85 would be an asterisk. So that would be how you create your box plot, okay, to construct your box plot. So you would be constructing it on a number line, and that would be how you would construct that. That 65 obviously should be just a little bit further over, but that is how you would make your box plot. Box plot always goes above the number line so that we can still see the number line, but we can also see your box plot drawn as well. Okay. As I scroll down towards the last things today, in the box plot there, you see it gives you some information on how to do a box plot. The next thing and kind of that you want to see is what you should use. So what's the best measure of center and spread? And we've kind of already talked about that, but we can go over a little bit more detail. If you have a symmetric distribution or one that's roughly symmetric, then the best measure of center is going to be the mean, the average, and the best measure of spread is going to be the range, or honestly, if you're using the mean, a lot of times we go with the standard deviation, right? Mean and standard deviation go together, and you'll see that later when we do the normal distribution. So if something's kind of symmetric, the best measure of center is the mean, the best measure of spread is the standard deviation. If something is skewed, which means there's a tail to the left or a tail to the right, a lot of times it means there's an outlier possibly. If you have a skewed distribution, the best measure of center is going to be the median, because the mean is going to get pulled with the outliers. The median is not. So in a skewed distribution, the best measure of center would be the median. Best measure of spread in a skewed distribution is going to be your IQR. That'll give you that middle 50%. So the Q3 minus Q1. So you kind of want to know that. So when you're presenting your data analysis, you kind of say, okay, is this a symmetric distribution? I'll use the mean and standard deviation. Is this a skewed distribution? I'll use the median and the IQR. And so hopefully that will help guide you through that. Here is an applet, if you're interested, about why we use n minus 1 when we calculate the standard deviation. So I'm going to show you how we calculate the standard deviation by hand real quick, because we will be doing that a couple times as we go through. So our first step in calculating the standard deviation is to find the mean. And we have found that the mean is 5. And then we want to find each individual value and say, how far is it from the mean? So for instance, this first number, 1, so like 1 minus 5 is equal to negative 4. 3 minus 5 is equal to negative 2. 4 minus 5 is equal to negative 1, and so on. And then how to calculate standard deviation by hand. So we want to go through and we want to calculate the mean. We want to calculate each deviation, as you see is done here. Then we want to square each deviation. So to square it, it's going to make them all positive, because standard deviation is how far you are away from the mean, which means it doesn't matter if you're below the mean or above the mean, it's how far away you are. So we're going to square each deviation. So like for number 1, that would turn into 16. This would turn into 4. This would turn into 1, and so on. And then we're going to find the sum of these. So we're going to add all of these up, all of these squared means. And then we're going to calculate the sum. And then we're going to divide by n minus 1. So when we add all those up, we get 52. N minus 1, so how many numbers do we have? We have 9 data points. Minus 1 is 8. So we're going to do 52 divided by 8, which is 6.5. Now, remember, that was squared, so that's still our variance. And to get the standard deviation, that's the last step, we would square root that 6.5, and that will give us our standard deviation of 2.55. Okay? So the square root of the variance is the standard deviation. So if you go through this whole process, this should add up to our variance. Our sum would be 52 right here for sum. Then you're going to divide by n minus 1. So you're going to divide by 8. That gives you 6.5. And then you're going to take the square root of 6.5, which gives us a standard deviation of 2.55. And that is how to calculate the standard deviation. And you will be doing more of that in the assignment. So if you need to look back at this video for anything, please let me know. Please make sure you have access to a TI-84 calculator. If you don't have access to a TI-84 calculator, please reach out to us. There is a Calculate 84, that's the name of it, app on iPhones. So if you are able to download that app, the Calculate 84 app, if you haven't done so already, that will look like the TI-84 calculator. And then there are some other options, maybe from the school, that we can help provide. But you do need a calculator as you're going through this, as there's a lot of calculations in statistics. All right, thanks, and have a great day.